Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome once again to all of you to the physics classes. We were talking about work, energy and power, and we have already discussed about work energy theorem. It says that to calculate the work done, you have to find out the kinetic energy. The change in kinetic energy if you find means you can find out the work done. Now what is the expression for kinetic energy? Kinetic energy is nothing but half mv square. Kinetic energy is nothing but half mv square. Now today here we are going to talk about potential energy. Kinetic energy is nothing but energy which is associated with the object which is moving. Okay, the potential energy is nothing but potential energy is the stored energy by virtue of its position. Say for example, potential energy is nothing but stored energy. Now one object is there, I will lift it and I will bring it here, I will keep it here. Means what I have done? I have done some work against the gravitational force and I have brought here. No, the work is done by the external force. Work is done by the external force. External force is me. Who is another force? Another force is gravitation. As soon as I leave, this object falls down. As soon as I leave, this object falls down. Why? The stored energy is there, stored potential energy is there, that will act as and it will convert as if like kinetic energy. Now what is potential energy? What is potential energy? It is nothing but work done by the external force. Work done by the external force. If an object is there means what is the force acting on it? mg, weight. If I have to lift that object means what force I have to apply? That is nothing but force into displacement. No, force into displacement. mg amount of force I have to apply. What is the distance I have to lift it? Okay, I am going to lift it for the distance h means, so the displacement becomes h. So this is nothing but work done. So which is equal to V of h, which is equal to mgh we are going to write down. So the potential energy we are going to represent in terms of V of h, V of h. Okay, but this is work done by external force. Work done by external force, that is potential energy. What do you mean by the work done by the gravitational force? Work done by the gravitational force is mgh itself, but it is negative, isn't it? I am going to pull it in the upward direction, but in always at each point that gravitational point is going to pull me down, isn't it? It is going to pull this object down in the sense for all the points that body, that gravity is going to apply the force and which is acting in the negative direction. The displacement is in the one direction, the opposite direction, the force is in the opposite direction. So I can write down like this. So here we are going to bring two terms, that is a force involved, right? For every work the force is involved. For every work the force is involved. There are two kinds of forces. One is conservative force, another one is non-conservative force. So first we are going to talk about conservative force. The conservative force is that where the work done by the conservative forces depends only on initial and final points. Only on initial and final point. Write down, conservative force is the force where work done by that force is depends only on initial and final points and it does not depend on the path traveled by that object. That you have to write down. Conservative force is that force, okay, the work done by the conservative force is depends only on initial and final position, and it does not depends on the path traveled by the object. Say for example, this object is there, I can take directly in this way. No, see, this object is here, I can take in this way also. If it is a mountain means, no, like this I can travel. So I can take this in this way also. No, same height is same, whatever may be the path, but it depends on displacement. No, so work done, this all the cases work done is same, means that is a conservative force, that is a conservative force. If the work done by the force is depends only on initial and final points, and it is does not depends on the path, then it is conservative force. Whereas non-conservative force means the force is said to be non-conservative. The force is said to be non-conservative if the work done by the force is depends on the path, okay, which is depends on the path. Which is conservative force? Gravitational force is a conservative force. Electrostatic force is the conservative force, whereas non-conservative force is friction, because on the path it is depends. No, I am applying different force in different in a tiles I am going to apply different force, in the rough surface I am going to apply the different force. Same, you are walking itself, no, but different force you are going to apply based on the path. No, that's why it is depends on the path. So this is non-conservative. We are not much interested about non-conservative force, we are talking about conservative force. Okay, conservative force is that way. Okay, now this is what potential energy we got. Now, and negative of this is nothing but, now I can say that this is nothing but work done by gravitational force, or I can say it is conservative force, work done by conservative force. No, work done by conservative force is minus mgh. Now, negative of work done by conservative force is mgh, isn't it? Which is equal to mgh. Then what I can say? Negative of the work done by the conservative force, that is nothing but mgh means what? That is potential energy. No, so negative of the work done by the conservative force is nothing, is potential energy, Okay. So now suppose I have taken this object to certain height h and it is having potential energy mgh. No, if I leave that object, what happens? It will increase the speed and hits the ground, right? What was the initial velocity? Was 0. What was the final velocity? Vf, or some v velocity. No, because I have kept, just I will drop it, means initial velocity is 0, final velocity is that. So what I can write down? V square, which is equal to v naught square plus 2ax, means it is gaining kinetic energy. No, so what is that final energy? V square, which is equal to 2ax. No, so x is nothing but h here, because initial velocity is 0, but kinetic energy is how much? Of mv square. So half m v square is how much? This much, 2gh. So 2 cancels, which is equal to mgh, which is equal to potential energy. So kinetic energy equal to potential energy we are going to get. No, what is the meaning of that? Kinetic energy equal to potential energy. The meaning is all potential energy of the body is converted into kinetic energy when it is reached mean. Whatever the stored potential energy is there, it is fully converted into kinetic energy. Whatever the stored potential energy is there, it is fully converted into kinetic energy when the object is falling, right? When the object is falling, simple. Now also I can say that what I am having, potential energy I'll erase this. Potential energy, that is nothing but V of H, which is equal to mgh. Now I am going to differentiate with respect to distance, that is nothing but h. So means dV of h divided by h with respect to t. It is not with respect to t, it is with respect to dh. Then mgh d of dh. No, V means that much. Now I can write down mg is constant, dh by dh, which is equal to 1. So it is mg. Now what I will do, mg is nothing but a conservative force, right? But it was negative, right? Conservative, see, I am taking this object to the certain height, but the conservative force was negative, no? Okay. So if I put negative here, the negative of the derivative, it becomes negative, no? So negative of okay, derivative means differentiation of potential energy is conservative force, no? These are all important in the competitive exam for you, okay? That is conservative force. That is what we can derive. The negative of the derivative of a potential energy is a conservative force. Okay, this is what potential energy is. So I'll erase this. So what I can write down, negative of dV by dh, which is equal to mg I can write down, or minus mg I can write down, no? I can write down, isn't it? Now minus mg is nothing but how much? Minus I will bring here. So dV minus mg into dh. So mg means what? Force. Mg is nothing but force. dh means what? dh means displacement, no? dh I can write down, or dx I can write down. So I am not supposed to change the notation, dh itself I am going to write down. So dV means what? dV means delta V is nothing but V final minus V initial, no? Delta V is nothing but V final minus V initial, no? Now dV means what? Again it is V final minus V initial, means potential energy final minus potential energy initial, minus of final potential energy minus initial potential energy. I will multiply that sign. So minus Vf I am going to get, plus Vi I am going to get, that is force into displacement, that is nothing but work done I am going to get. So that is nothing but work done in the variable force, right? That is work done in the variable force, no? That is work done, that is total integration if I do means, okay. So I have to get dV means I can get again in that way kinetic energy, work energy theorem in the case of variable force is there, no? In the same way I can do integration if I do means I am going to get V here, okay, delta V I am going to get, which is nothing but work done. So f of x dx I am going to get, no? xi to xf, okay, but it is negative of that, Vi minus Vf you are going to get, means again the work done also I can write down for the conservative force only, the negative of the potential energy I can write down. Work done is nothing but the negative of the potential energy I can write down. Work done is nothing but negative of the potential energy. Work done is equal to change in kinetic energy. Work done is equal to change in potential energy, but it is negative for what? For the conservative force. This is for only conservative force, not for all, okay. This is for conservative force, and this is what we got. So you have to study here only potential energy, the expression of potential energy you have to study, okay. The expression of potential energy, and these are all these things, this is for the competitive exam is important, okay, and also for the knowledge purpose it is important for you. So go through it once again, okay, and repeatedly study, work out for all the topics. For time being, for today's class, we are going to conclude here, okay, about potential energy. Okay, thank you very much.
Don't forget to like our video and subscribe our YouTube channel for all the updates.